Hello students, in this video we are going to discuss the motion parameters of a body projected vertically upwards. This is a body which is thrown vertically upwards. After reaching certain height, the body will comes back to the original position. Suppose say we are throwing this body with velocity u. Its velocity goes on decreasing and its magnitude will become 0 at the topmost point. And it will change its direction and increases towards the ground. I am naming it, it is the point A, point of projection, maximum height. The point is suppose say B, and again it is coming back to the point A itself. And the height reached by this body, I am writing H suffix maximum from A to B. Here, the velocity at the topmost point is an example for 0 vector. Here what we are going to discuss. From the parameters, the first one we can name maximum height. So what is the value of maximum height? If you apply equations of motion, v square minus u square is equal to 2as. Here I am taking a is equal to minus g, that means g is always downwards, and S value is nothing but H maximum, and the final velocity is 0. Then in that 0 square, that means 0 minus u square is equal to minus 2gh maximum. From this, H maximum is equal to u square by 2g. If a body is projected upwards with velocity u, the maximum height reached is equal to u square by 2g. From this we can write H maximum is directly proportional to u square because 2g is constant. And coming to the second parameter, the time of ascent. I am writing it is T suffix A. For a body projected upwards, the time to reach the maximum height is called time of ascent. I am taking V is equal to U plus AT, the first equation of motion. Here A is equal to minus G and T is equal to T suffix A and V is equal to 0. From this I will get 0 is equal to U minus G T suffix A. From this u is equal to g t suffix a, that means time of ascent is equal to u by g. Here also time of ascent is directly proportional to u. We are taking g is constant. and the parameter 3. Time of descent. What is meant by time of descent? For a body projected upwards, the time to travel from maximum height to the point of projection on the ground is called time of descent. That means from the ground to reach maximum height from point A to point B, time taken is time of ascent, where its velocity is 0, and the time taken from maximum height to again to the point of projection is time of descent. Here we know H maximum is equal to U square by 2G, and if I am using S is equal to ut plus half at square in the case of downward motion. In the case of downward motion, u will be 0. That means here in the case of vertically upward thrown body, v becomes final velocity. In the case of freely falling body, the final velocity is acting as like initial velocity here. So u is equal to 0 and a is equal to plus g, and t is equal to time of descent, and s is nothing but H maximum. Therefore, H maximum is equal to half gt square, and this H maximum is u square by 2g, that is equal to half g td square. And from this, time of descent square is equal to, we will get u square divided by g square. So time of descent is equal to u by g. From this we will come to know time of ascent is u by g and time of descent also u by g. But be clear here, we are ignoring the air resistance. We are ignoring air resistance. So in the absence of air resistance, in the absence of air drag, time of ascent is equal to time of descent is equal to u by g. Now the parameter 4. Time of flight. I am denoting it with capital T. For a body projected vertically upwards, the sum of the time of ascent and time of descent is called time of flight. It is the total time for which the body remains in the air. So time of ascent plus time of descent is equal to time of flight. That is u by g plus u by g, that is 2u by g. Here also the time of flight also directly proportional to the initial velocity of the body which is projected. Coming to fifth point. Velocity of the body on reaching the point of projection. Velocity of the body on reaching the point of projection. The body is falling down from height h, that is nothing but h maximum. Initial velocity is 0 here. Now, from v square minus u square is equal to 2gh formula. V square is equal to 2gh maximum or h. So V is equal to square root of 2gh. Be clear here. When a body is projected vertically upwards, at the point of projection, whatever the velocity we are giving the body upwards, the same amount of velocity the body will gain while it is reaching the same point. But the direction of the velocity here is reversed. At any point, the magnitude of the upward velocity is equal to the magnitude of downward velocity. And the time of ascent is equal to time of descent also. In the case of vertically upward thrown body, final velocity is 0. In the case of freely falling body, for the same height, initial velocity will be taken as 0. So, for the vertically upward thrown body, if you are taking initial velocity is u. For freely falling body, if you are taking the final velocity is v. These two will be equal. So, what is this value? Is nothing but equal to root 2gh. Okay. Now, what are the graphs related to this? So, graphs for a body projected vertically upwards. It is position or displacement along y-axis, time along x-axis. When time t is 0, the position is 0, then the position increases. Finally, the position or displacement is 0. When it is reaching the maximum height, that is u square by 2g at the time of u by g, and at the time of 2u by g, that is reaching the same point. And velocity time graph. Be clear here, v is velocity, not the speed. Initially, the velocity of the body is u. its velocity goes on decreasing and becomes 0, where it is becoming 0 at the time of u by g, and again increasing in reverse direction, it is minus u, and here time will be 2u by g. While coming to acceleration time graph, here in the case of vertically upward thrown body, we are taking a is nothing but equal to minus g. So these are the position time graph, velocity time graph and acceleration time graph for a body which is thrown vertically upwards. Now, for the graphs, in the case of freely falling, for a freely falling body, for freely falling body, position or displacement versus time, the graph will comes like this. Y means h is of gt square. So h or s is directly proportional to t square. In case of freely falling body, h is of gt square, of g is constant, h is proportional to t square. So the graph will comes like this. In the case of freely falling body, v is equal to gt. So v is directly proportional to time. This one will be a straight line passing from origin. So, and while coming to acceleration versus time, in the case of freely falling body, we are taking acceleration is plus g. So the graph will be a straight line parallel to time axis. Be clear here, the positive or negative directions are a matter of choice. You may take another choice also. Thank you.